Okay, so for the second day of trig functions and real numbers, we're going to talk about angles on any circle. So in the previous lesson, we talked about angles in the unit circle, so specifically where the radius of the circle was 1. And so in this case, the radius of our circle is not always 1, so we're going to call it r. So if we are looking at the unit circle and a triangle in it again, the side opposite theta is y, the side adjacent to theta is x, and the hypotenuse now, instead of being 1, is always going, oops, I used red, I think, is going to be r. So the adjacent side is x, the opposite side is y, and the hypotenuse is r. So when we're thinking about SOHCAHTOA, sine of theta is not just y anymore, so it's going to be y over the radius of the circle. Cosine of theta is not just going to be x anymore. I used the wrong color for r, sorry. Y over the radius. And then cosine is x adjacent over hypotenuse r. And tangent is still opposite over adjacent, so y over x. So from what we learned in day 1, tangent is the same. So when my circle is not a unit circle, these are the formulas that we're going to use. Again, you will need to know these for your quiz. So make sure that you memorize them. Ultimately, if you want to just memorize these and then remember that the radius of the unit circle is 1, then they really are the same equations as we talked about last time. So remember that in the unit circle, we have a right triangle, so a squared plus b squared equals c squared. If we think about the legs, those legs are the x and y coordinates. So what we're going to use for these is x squared plus y squared is equal to r squared. So the r is the c value in the unit circle, and then x and y are a and b. So again, I'm just keeping it alphabetical. So what's going to change here is that since we're using a circle in the coordinate plane, we're going to talk about quadrants. And so the quadrants dictate the sign, and sign meaning like positive or negative sign of the trig function. So there's a mnemonic that we use to help us with this. And so it's all of them are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And cosine is positive in quadrant 4. And so the mnemonic that we use is all students take calculus. And so each time that we're solving a problem, I'm going to really draw out the coordinate plane and put whichever letter that corresponds to all students take calculus that we're talking about. And so when we're given a problem here, we're going to be given 2 pieces of information. We're going to be given one of the 3 trig functions and the quadrant that we're working with. And then we're using what we know about the triangles and stuff to identify the values. So the quadrant piece is really just telling us whether our answer should be positive or negative. And so I'm always going to start with that quadrant piece and kind of set up our problem. So if I'm in our quadrants, all students take calculus, this is asking me about quadrant 3. So in quadrant 3, tangent is positive, and so that's the only trig function that is positive, so that means that sine is negative. Okay, so what I'm going to do here is I'm really just setting up my answer to know that it's supposed to be a negative value. So since tangent is positive, this tells us that sine is negative. If I was finding, notice cosine is negative as well. So that's step one. The next thing that we're going to do within this is we're identifying sine of theta. So if they're giving us cosine, remember cosine of theta is x over r. Okay, so really I'm just looking at the value. So x is 3 and r is 5. I'm ignoring that negative. That negative had to do with the quadrant. We've already figured out the quadrant. Okay, so we need to know x, y, and r to be able to identify any part of the triangle to find a trig function. So we know that the radius is 5. We know that sine is y over r. So I know that the denominator here is 5. What I don't know is what the numerator is. So I have to think about the triangle and solve the triangle in order to figure out my value for sine. So ultimately, I'm each time just going to draw a generic triangle. So the opposite side is what I don't know. I do know the adjacent side is 3, and that the hypotenuse is 5. Okay. So what I have to look at then is using the Pythagorean theorem, what is the missing side from the triangle? So some of you might know this just by looking at the triangle, what the answer is, but I'm going to go through the process. So to do this, I'm using the formula x squared plus y squared equals r squared. So I don't even necessarily need to draw it. So x squared plus y squared equals r squared tells us that 3 squared plus y squared equals 5 squared. Okay, so 9 plus y squared equals 25. If I subtract 9 from both sides, y squared is equal to 16, which means that y equals 4. So that means that sine of theta, when cosine of theta is negative 3/5 and the angle's in quadrant 3, is negative 4/5. Okay, so I'm going to do one more in this video, which is part B. So for B, they give us sine of theta instead of cosine of theta, and they want us to find cosine. So this time we're in quadrant 4. So if we're thinking all students take calculus, in quadrant 4, cosine is positive, okay, and that's what we're looking for. So that tells us that whatever our answer is, it's a positive answer. Okay, so we're identifying what is cosine, given that sine is negative 1/7. Okay. So sine being negative 1/7 tells us that y is 1 and r is 7. So to figure out the value for x, because cosine is x over r, so it's something over 7, we want to do the Pythagorean theorem. So x squared plus y squared equals r squared. So x squared plus 1 squared equals 7 squared. So x squared plus 1 is 49. If we subtract 1 from both sides, x squared equals 48. And so if we take the square root of 48, we need to figure out what perfect square factors go in. And since we won't have a calculator, we do need to do this using our hockey stick method. So if I divide 48 by 2, that gives me 24. If I divide 24 by 2, that gives me 12. 12 divided by 2 is 6. 6 divided by 2 is 3. And then 3 is prime. So that's going to be our last number. So since there are 2 pairs of 2s, I can take out a 2 and a 2. So 2 times 2 is 4. And then I'm left with 3 times 1. So the cosine of theta is 4 times the square root of 3 over 7.